Hi, and welcome to our ThinkPlus gamification project presentation. We are a group of 5 people: Kim Long Lei, John Eliadius, Damien Desio, Do Kwang An, MD FD Inam Aiswajo. So without further ado, let's get started.
In the 2024 NAPLAN test, it was revealed that 1 in 3 school students failed to meet new proficiency standards for literacy and numeracy. Additionally, it was shown that around 10% of students were so far behind and in need of additional support. This can be attributed to several factors, such as student lack of engagement/motivation in studying, learning disabilities, or mental and emotional health issues. Our client, the Elevo Institute, aims to improve teaching and learning by incorporating the ThinkPlus curriculum in Australian schools from years prep to 12. The aim of the curriculum is to help students understand how their brain functions and how emotions are constructed, which in turn aids in the development of emotional resilience, problem-solving skills, and a greater capacity for learning. The core concepts of the curriculum include neuroplasticity, the brain's ability to adapt and form new neural connections through learning experiences, mindsets and emotions, the set of beliefs a person holds about themselves, which affect the way they approach challenges like learning, and the last one is metacognition, which is the awareness and understanding of one's own thought process. For this capstone project, our team has been assigned the task of gamifying the ThinkPlus curriculum. As a final deliverable, we have created prototype/proof of concept game, which will serve as a demonstration to secure funding for the full development. Our initial plan was to create a browser-based open-world RPG-style game using the Unity game engine. The open-world RPG format gives students a sense of exploration and freedom, helping to maintain engagement while still allowing us to embed structured educational content. The rationale behind the game being browser-based is that it allows easy accessibility on school computers without requiring any specialized hardware or software installations. For the gamification of the curriculum, the game consists of the following key features. First, the ThinkPlus world, which consists of 3 ThinkPlus islands and a main map. Each island is themed according to its corresponding ThinkPlus topic. For example, the Metacognition Island is a snowy and mountainous region, based on the metacognition motto, drive your own learning. The main map will serve as the central hub and the primary spawn point. Next one is minigames. So each minigame will be themed based on a particular ThinkPlus lesson of the curriculum, and minigames will be accessible via game portals. Next, the educational system consists of the concept of masters and guardians. The masters are responsible for delivering educational lessons, while the guardians are responsible for assessing the player and granting access to the minigame portals. Finally, the quest line includes an onboarding quest to introduce players to the game and a series of educational quests that guide them through the ThinkPlus curriculum, providing a clear learning roadmap. To tackle this project, we incorporated the Scrum development methodology, using Jira to manage the backlog and structure sprints. The work was divided across 2 semesters. In semester 1, our focus was primarily on planning and design. We began with requirement engineering, which consisted of researching the client and holding weekly meetings to define the project scope, stakeholders, functional and non-functional requirements. From there, we worked on game design, conceptualizing the game mechanics, progression systems, and the integration of educational concepts. Finally, we created the game design document, which was used as the primary reference for the development. In semester 2, we focused on the implementation of the game. The process was split into 4 sprints, where each sprint focused on developing a specific component of the game, such as world building, game UI, the minigame, etc. Each week, the team held meetings to evaluate progress, and at the end of each sprint, a sprint review was conducted.
For our project achievements, we started with just a short brief and turned it into a fully playable game. We deployed the build to Unity Play and flawlessly met the client's expectations. We also delivered a live demo over Microsoft Teams to a representative from the Elevo Institute and received strong positive feedback, which validated our directions and execution. On the product side, we made a ton of progress. We integrated a full dialogue management system that supports dynamic NPC conversations, We also developed a dynamic scene switching system with dynamic spawn points that adjust based on context for flexible level transition scenarios. We built a custom character customization system to let players personalize their own avatars. This has over hundreds of customization options to choose from, and we developed our own movement and interaction system from the ground up, tailored specifically to our game needs and not relying on any other third party templates. We conceptualized and built 5 unique maps, each with its own layout, theme, and gameplay loop. Each one starts with a cinematic intro to help immerse players into the space. These maps include NPC with interactive dialogue and one kid-friendly minigame designed to teach emotional education, which aligns with the Think Plus curriculum. We also designed a clean, intuitive, and visually appealing UI tailored for young players. In addition, we also prototyped an inventory system and a journal entry system to support future content. And lastly, we built a foundational building system in the Mindscape area, allowing players to place structures and shape their environment. Overall, we hit every major milestone and delivered a stable, modular, and scalable foundation ready for future iteration.
Here are go-to challenges that our team faced during each phase of the project. Computing Technology Project A, Excessive Ambition. We spent an entire semester coming up with numerous ideas for the project, but at the end of this semester, a lot of ideas were scrapped off due to our limited experience and time management. Computing Technology Project B, Spring 1, Assets Implementation. It took way more time than expected to purchase the assets for the game, resulting in delayed world building. Not to mention, when importing assets into our project, several problems arise such as render version uncompatibility error, which took even more time for us to finally start making the game. Spring 2, Implementation Difficulty. Due to the limited availability of reliable resource and documentation for Fitness, the multiplayer framework selected for the project, we decided to pivot away from multiplayer for the demo version, opting for a manageable single-player focus. The original player movement system was also a problem with several bugs that we had to implement a brand new one. Performance issues. The file of the Plus maps were too big that affected the game load time and responsiveness. To address this, we looked into exploring Unity addressable access system and asynchronous loading techniques to optimize performance and ensure a smoother player experience. We also sacrificed a part of the map visual to prioritize performance. Spring 3, Game Hosting Issue. While hosting the game with Unity Play, there is a visual issue where some of the material are pink. This occurred because of the affected assets were not using universal render pipeline compatible shaders. This has caused a big delay in the project as each unit asset had to be manually changed to use the URP need shader, which means the textures also need to be appropriately reassigned. Task reassignment. Because some members in our team struggle with completing the tasks assigned to them, we had to spend time discussing which tasks are suitable to assign to them, while the uncompleted assigned tasks would need to be reassigned to someone else. And finally, we have Spring 4, Time Constraint. The type timeline placed significant pressure on the team due to the time limitation. Neuroplasticity minigame and metacognition minigame could not be implemented. The focus shifted to developing a complete foundational experience, deferring this game to a future development phase. As mentioned above, the initial scope was too large. As a result, a lot of features had to be cut out. We prioritized the most critical features to ensure a stable, playable, and polished demo game.
We began by identifying the core educational goals of Think Plus, teaching neuroplasticity, mindset, and metacognition to children aged 6 to 12. After brainstorming potential gameplay formats, we settled on a 3D game world that encourages exploration, collaboration, and learning through minigames. The visual and interaction design focused on accessibility, simplicity, and engagement for younger players. Each area in the world was thematically tied to a cognitive skill. We used Figma and Miro for early mock-ups. A robust dialogue management system was integrated to handle interactive quest lines and curriculum-based quizzes, allowing players to engage with educational content in a narrative-driven format. The world was divided into 5 distinct maps, each themed around a specific cognitive concept. At the center of it all is the Think Plus town, the main hub where players customize their avatars and access other zones. Unity was the primary game engine used for building the project, chosen for its flexibility and web platform capabilities. The final game was exported using Unity's WebGL build pipeline and hosted on Unity Play, allowing the game to be accessed directly through a browser. GitHub was used for version control and team collaboration, enabling code management and tracking across the development.
Reflections on communications. In case of team, throughout the project, our team maintained clear and consistent communication using tools like Microsoft Teams, Discord, and Jira. We held regular meetings, shared progress updates, and ensured everyone was aligned with the sprint goals. This helped us resolve blockers quickly and distribute tasks effectively. The openness and mutual respect in our communication greatly contributed to team cohesion and overall productivity. If you move to supervisor, like our academic supervisor played a vital role in guiding us throughout the semester. We maintain an open communication channel, regularly updating him on our progress, blockers, and next steps. His feedback helps us refine our planning and prioritize development tasks. And on the other hand, in case of client, we actively engage our client during every sprint, especially during milestone reviews and feedback sessions. The client consistently provided valuable insights, and we ensured all concerns and suggestions were implemented promptly. By sharing regular updates and staging builds, we kept the client informed and involved, which ensured the final product matched their expectation. Now, if I mention overall feedback, the client expressed great satisfaction with the final product, especially in how it blended education with the gameplay. He appreciated our responsiveness to feedback and professionalism. He described our team as one of the best of the semester and recommended HD grades for us in his feedback email to the convener. And moving to the supervisor feedback, our supervisor consistently commended our consistent work ethic, sprint progress, and teamwork. He recognized our efforts in producing a polished product and noted that we were the top 3 groups he was supervising.
And that has been our final presentation. Thank you for listening.